Yo, what is going on, guys, and welcome back. We're starting section 4 in part 4 called definite iteration. And this is where we also get into some more fun stuff in programming, especially I'm talking in general, but also as we're learning Python, and that is using other types of loops. So, as I always do, I took a quick gander at the material for this section, and we're going to be learning about for loops. And for loops are one of the most common types of loops that you'll see in programming across the board. They are an awesome way to do iterative uh, looping or iterations in programming, especially if we know how many times that we want to loop. We've seen with while loops, for example, they're really good in they're more useful when you don't know how many times you want to loop. So we've structured our while loops in the past using the while true conditional, where essentially we initialize our loop to always run until inside of the loop we set some sort of terminating condition that will kick us out of the loop. But with for loops, which we'll dive into once we start reading the material, we can tell Python how many times we want to loop from the jump. Now, we've also been able to do that with while loops using uh, helper variables, but with for loops, you kind of define that in the loop itself. Like we tell Python or we tell whatever programming language that we're using that we're writing our for loop in how many times we want to run that loop. So for loops are pretty common in programming. You will see them across the board, not just in Python, but any other programming language. And we're finally going to learn how to write for loops in Python in this section. So just like I did in the last video, I'm going to split screen this. Actually, you know what? I'll keep it full screen for now. But just to talk about VS Code here, we have it open. I have all the exercises that we're going to be going over in this video. There's about 12 of them that I have open. Again, you can do that by going to the TMC tab on your VS Code window, hit Python programming, give it a second to load up, and then scroll down to part 4, hit show exercises. So all the exercises we've completed up until this point, you can see the check marks here under the completed column. So, pardon me, hold on a second. So yeah, we've done all the way up to exercise 19, which was the last exercise we covered in the previous video. Now we're gonna start from exercise 20, I think all the way down to somewhere around here. Shortest in list or distinct, I think it's distinct numbers. Something, let's just double check here. Okay, all longest in list. So we'll go down to exercise 31. So which also shows us that we're getting pretty close to the end of section 4, because after we get to exercise 31, there'll only be, what is this, like 7 exercises left to do. So we're getting pretty close to the end of section 4. I think we'll probably be able to get through it in the next like 2 or 3 videos. Now, if you want to open just the exercise that we're covering in this video, if you have, maybe you had the entire course exercise, section exercises listed down here, all you have to do is just click this button, this checkbox here, to select all the exercises. You're gonna see this little pop-up here telling you how many exercises that you have open. Hit the close button, then uncheck everything, scroll down from exercise 20, star studded, all the way down to, and just check each one all the way down to exercise 31 here, all longest in list. And then once you do that, just for demonstrating purposes here, for example, I'll select like a couple here. You'll see, again, this little box will show up again. Just hit open. And when you go back to your file explorer over here, it's going to show those exercises listed onto the file explorer on the left side of your VS Code window. So I have these exercises open. So it's going to be going back and forth in, as we progress, as we're reading the material and progressing down the material. And each exercise that comes up, we'll just go down here and open it individually, open the source folder, double click it, and we'll write our solutions in here. So that's all I wanted to cover for that. I like this split screen thing that we were doing in the last video, but I think for this one, I'm just gonna full screen and alternate. It's gonna kill my frames, but it is what it is. I think it's just a little bit easier to read and follow along. But one thing that I haven't been doing is zooming in a little bit. I think it might be a little bit easier to read, so I'm gonna just zoom in so we can be able to read and it'll be appearing a little bit clearer on small screen sizes. If you're watching this video on your phone or whatever, it might be a little bit easier to read and follow along. Okay, section 4, definite iteration. The learning objectives for the section is that you will know the difference between definite and indefinite iteration. You will know how a Python for loop works. Yay, we've been waiting to learn this. And all solutions that I've been giving you guys and we've been going through for every exercise up until this point has been using the while loop because I didn't want to introduce a new concept or a new programming approach that we didn't learn yet. So I tried to keep all my solutions very close to the material that we've learned up until this point, unless it's like something that I think should have been covered but hasn't been covered and is useful for some solutions. Then I'll talk about it, or I'll show you how to do that in Python. But some of the big stuff like for loops and other types of loops that we haven't learned so far, I'm not going to use those. We haven't learned recursion yet, so I haven't shown you solutions that use recursion, but that's also another way to loop in programming. But in this video, we're going to learn about Python for loops. And you will be able to use a for loop to iterate through lists and strings. Okay. You can use a while loop to go through the items in a list, just like we used while loops to go through strings. The following program prints out the items in the list, each on a separate line. We have a variable here called my_list, which is assigned this list of integers. They are in no discernible order. It's just integers, 3, 2, 4, 5, 2. It's not in ascending order. It's not in descending order. It's just a list of integers. We have here a variable called index, which is assigned the integer value of 0. This is going to be used in our loop for iteration purposes, which was what I was talking about at the beginning of the video. Now here we have our while loop, where we say while index is less than the length of our list. We print the value from our list as we iterate. So, and then we increment index by 1. So when our loop first runs, index is equal to 0, and 0 is less than the length of our list. The list has 5 values in it. So 0 is less than 5. So then we print what the item in our list at that index. So at index 0, print what that value is, and it's 3. Then we increment index by 1, so we move index up forward, and so on and so forth. So this is going to print 3 first when index is 0. When index is 1, it's going to print 2. We increment index by 1, so index becomes 2, and it's going to print 4, right? This value here, and so on and so forth down the length of the list. Now we've seen this approach many times. I've showed it on video before. We've seen it in these sample programs that are written in the course material. So this is nothing new to us. This obviously works, but is a rather complicated way of going through a list, as you have to use a helper variable, index, to remember which item in the list you're at. Fortunately, Python offers a more intuitive way of traversing through lists, strings, and other similar structures. The for loop. When you want to go through some ready collection of items, the Python for loop will do this for you. For instance, the loop can go through all items in a list from first to last. When using a while loop, the program doesn't know beforehand how many iterations the loop will perform. Exactly. So as we've seen with while loops, we never know how many times this loop will run unless we structure it like this, where we have a helper variable helping us keep track of where we are, and a way for us to reach some sort of terminating condition, right? Some sort of condition that's going to kick us out of this loop. While loops can run forever, right? While like a certain condition is true, then this loop can go on forever. So if this list was, for example, an infinite length, right, then this loop can run forever. As we've also seen when our loop is initialized with while true, right? As long as nothing changes inside of the body of the loop that is going to force us to exit our loop, that while loop can run forever. When you want to go through some ready collection of items, the Python for loop will do this for you. For instance, the loop can go through all items in a list from first to last. When using a while loop, the program doesn't know beforehand how many iterations the loop will perform. it will repeat until the condition becomes false or the loop is otherwise broken out of. And we've seen this where inside of our loop, we can have some sort of like an if statement. And if that condition being checked in the if statement is true, then we can tell Python, hey, kick us out of this loop. That is why it falls under indefinite iteration. Indefinite meaning we don't know how long, we don't know how many times. Indefinite iteration meaning we don't know how many times we're going to be iterating over and over and over again. With a for loop, the number of iterations is determined when the loop is set up. And so it falls under definite iteration. So definite meaning we definitely know how many times we're going to be doing a certain action, or how many times we're going to be looping over something, or how many times we want our program to run itself over and over and over again, right? We can define that from the very beginning when we're defining our loop. The idea is that the for loop takes the items in the collection one by one and performs the same actions on each. The programmer does not have to worry about which item is being handled when. The syntax of the for loop is as follows. I need to repeat this. The idea is that the for loop takes the items in the collection one by one and performs the same actions on each. The programmer does not have to worry about which items is being handled when. Right? We don't have to remind or tell Python to handle each item. Right? The for loop will automatically infer some of that stuff for us, so that we don't have to worry about if we're in, for example, if we're out of bounds, if we're going through a string and it's an index out of range, or an error like that, right? The for loop will automatically know that. So if we're not careful, for example, with while loops, if we want to iterate through a string, right? If we are not using less than as opposed to using less than or equal to the length of a string, we can end up causing an index out of range error or something like that. But for loops, we don't have to worry about that stuff. It just takes care of that for us. So this is the anatomy of a for loop. So we say for variable in a given collection, then do something with it. So for example, if we were looping through a list, we could say for item in list, right? We'll put our list name here. So for item in my list, my underscore list, then do something to it. So we could print that item. We could, mutate it to a different value, right? As you can see here, we don't even have to increment, right? We don't have to say for item in our list, print that item and then increment item by 1 so we can move on forward to the next item, right? Python will do that for us. So it's going to say for each item in our collection, do a certain action. The for loop takes an item in the collection, assigns it to the variable, processes the block of code, and moves on to the next item. When all items in the collection have been processed, execution of the program continues from the line after the loop. So here, imagine this is our code, but written in this flow diagram. We approach the for loop here, and so the for loop is going to check, are there more items in the list? If true, go to the next item, store it in our variable, and then execute those instructions inside the for loop block. And then go back up and check again, are there more items to process? And then repeat. If there are no more items to process, basically if this condition is false, then exit the loop and go continue on to the rest of our code. So here we have an example of a for loop being defined and used. The following program prints out all the items in a list using a for loop. We have a variable here called my underscore list, which is assigned a list of integers. Then we say for item in my underscore list, print that item. And then Python is basically going to say, so treat this, we're assigning this variable item to each index, right, and its value in our list. So we don't have to define a new variable to track the indexes. Item covers that. And item also covers the value of that index. So when we say for item in my list, it's going to be traversing 0, 1, 2, 3, 4. And then for each index, print that value. So here, it's going to first go for index 0, it's going to print 3, go to index 1, print 2, go to index 2, print 4, go to index 3, print 5, and go to index 4 and print 2. right? We don't have to worry about incrementing as we would in a while loop. For example, we'll have like a helper variable here, so index is equal to 0. We want to print index at that list and then increment index by 1 so we can go forward. But with a for loop, we don't have to even worry about that. We can just print each value in our list and not worry about manually ensuring that our program increments over and over and over again. Compared to the example at the beginning of this section, the structure is much easier to understand. A for loop makes straightforward traversal through a collection of items very simple. This is a fact. Well, an opinion, but yeah, it does. It makes things so much easier to do. The same principle applies to characters in a string. Here we have a variable called name. It stores a string input that we prompt the user for. Here in this instance, we're prompting the user to input their name. Then we have a for loop here. For a character in name, print that character. So here, when we prompt our user and they type in Grace, it's going to take that string, isolate each character, right, each index, and then print that index. So it's going to print Grace, right? If you remember, in a while loop, if I can just, let's go to the Python playground here for a second. Okay, I have the Python playground set up over here, right? If you remember, we could say name is equal to input. Please type in your name. And then we can say while, we can say index is equal to 0 while index is less than length of name. Then we can print name index like this. And then we have to index is equal to index plus 1. When we run this, I'm going to write my name, and then it's going to print stephen like that, right? But we have to manually have a helper variable here that's going to help us traverse our string. And we also have to tell Python that we only want to traverse when we're using a while loop, that is. We want to loop for as long as the string's length, right? But here's how we do it with a for loop. So here I'm going to print traverse name with for loop, and here I'm going to do traverse name with while loop. Right? Now here I'm going to do for, I'll say character in name, print character, right? Oh, pardon me. Right? Look how much shorter this loop is compared to here, right? I mean, granted, it's only one sentence. I mean, one line shorter. But its construction is also a lot smaller, right? I don't have to tell Python that we want to do this for the length of the string, right? Python knows that is going to infer that we want to loop for as long as our string is. I don't also have to manually have a variable here, a helper variable, that's going to help us target each index in our string. We just assigned this character, we just define this character. We don't define it, but we tell Python to treat each index in our string and assign it to this character variable and then print that character variable. So when we run this, as you can see, again, I'm going to type in my name. They do the exact same thing, but this is just so much shorter. We don't have to. In fact, let's say, for example, I was to get rid of all of this, right? If I wanted to write a program that prints out each character in a string like this, look at that. It's only 3 lines long. But if we do it with a while loop, for example, like that, oh my God. Right? Now we have to do almost 6 lines here of code. So it's just a way shorter and cleaner way of working with strings, with looping, with lists, and whatnot. So hopefully that helped you kind of see the benefits of using for loops. Aside from also the bigger picture here is that with for loops, they're useful when we know how many times we want to iterate something, right? How many times we want to do something over and over again, as opposed to that's why they call it definite loops, as compared to a while loop, where while loops are by nature indefinite loops, right? We don't know how long they're going to be running for. That's why we always have to make sure when we're using a while loop that we always have to have a way for us to break out of this loop because it's so easy for us to fall into an infinite loop. Okay, here we have our first exercise called star studded. It says please write a program which asks the user to type in a string. The program then prints out each input character on a separate line. After each character, there should be an asterisk, right? A star, an asterisk, printed on its own line. And this is how it should work. So here we have a string Python, then we print P, followed by an asterisk, then there's a space, then it prints Y, followed by an asterisk, then there's a space, then T, and then so on and so forth, all the way down until the full string is printed out. This exercise does not ask you to write any functions, so we don't need to worry about this. So I'm gonna go and open up VS Code. Got VS Code opened up. We're gonna open this star studded file, folder. Go into the source folder. Click on the star_studded.py. I'm gonna zoom in a little bit. And so we know we have to prompt the user for a string input, and the prompt is just to please write in a string. And then we're just going to do is for character in string, print character, print that asterisk, and then let's run this. I can't see the play button, so we're going to do what we did in the last video. And we're going to go into the, for a second, what exercise did we do? Right, so this is the folder, part 04. Copy that, change directory to that folder, and then change directory into the source folder. Then I'm going to do Python and star_studded.py. So here for write Python, and there we go. P followed by an asterisk, Y followed by an asterisk, T followed by an asterisk, and so on and so forth. So this should be the solution. I'm gonna hit this I button here, which is gonna run our tests, see how we do. There we go, we passed. Send the solution to the server so we can get credit for it. Okay, I'm gonna open that model solution in a second. Let's just go back over here, hit this refresh, and there we go, we got credit for that one. Now I have to log in here because if I don't, then we're not gonna be able to see the model solution, but it's gonna be pretty close or pretty much what we just wrote in VS Code. So give me 1 second to log into the TMC website. Okay, this is the solution, the model solution. Again, they have a string here that prompts the user for an input, and they use a for loop for character in string, print that character, followed by printing the asterisk, which is exactly what we put over here in our code. So I'm gonna go ahead and close that. I'm gonna figure out how to get that play button back up here for a second, so before we continue. Okay, I figured out why that run button over here for run Python file was not showing up is because I had disabled the Python and Python debugger extensions. I'm pretty sure if you just right click on it and click enable, it should enable all the other Python extensions wow. Yeah, so if you go to the extensions tab, and in case you're having this issue, I just gotta give it a second here because I'm dropping so many. Right, if you go to your extensions tab here, just click this, or you can hit Control-Shift-X on your keyboard. Then come up here and look for Python. Right, make sure you have these enabled. If you right click on this, on the main Python one, we installed this when I was showing you guys how to get VS Code and set it up for this course. But we had to install this Python extension. Now, if I have it running, it's gonna absolutely drain my computer RAM. So that's why I keep it off. And this is what's attributed to having that run button up here missing. But as I've shown you, you can also run your programs straight in the terminal window down here. So we're not gonna worry about this too much. But if you're having the same issue where the run button over here is not showing up, this is probably why. Just right click on here, enable it, or you can enable it in this workspace. So every single time you open the TMC workspace, then this extension is always on, but I'm gonna keep it off because it genuinely drains my computer memory. Okay, so we got credit for this exercise. We can see the green dot here. So I'm gonna go ahead and close this. I'm also, just for the sake of being prepared, I'm gonna go and change directory into the part 4, exercise 21, negative to positive folder. Change directory, clear, change directory into the source folder in here as well. So we're just ready to run this program. Okay, let's go back to the course material and continue reading. The function range. Often you know how many times you want to repeat a certain bit of code. You might, for example, wish to go through all the numbers between 1 and 100. The range function plugged into a for loop will do this for you. There are a few different ways to call the range function. The simplest way is to give the function just one argument, which signifies the endpoint of the range. The endpoint itself is excluded, just like with string slices. In other words, the function calls range n provides a loop with a range from 0 to n1 minus 1. So here we have a for loop for I in range of 5, print I. Now this is going to print 5 integers, but it's not going to print the integer 5 itself, right? It's excluding the endpoint. It's going to, remember, in Python, we're zero-based indexing, or we start counting from 0 when we're looping or we're iterating through a list or a string. So in this instance, our first integer printed is going to be 0, then 1, then 2, then 3, then 4. Again, this is 5 integers, but with excluding 5. So it's always going to be n minus 1. If n is 5, it's going to print up to n minus 1, so it's going to print 4. If n was 100, it's going to print from 0 to 99, even though that's still 100 integers being printed. With 2 arguments, the function will return a range between the 2 numbers. The function range a comma b provides a range starting from a and ending at b minus 1. So for I in range 3 comma 7, print I, it's going to print 3, 4, 5, 6. So 7 minus 3 is 4. It's going to print us 4 integers, excluding the ending of our range. Finally, with the 3rd argument, you can also specify the size of the step the range takes between each value. The function called range a comma b comma c provides a range starting from a, ending at b minus 1, and changing by c with every step. So for I in range 1 to 9, right? So this is going to print 8 integers, increase by 2. So it's going to print 1, then it's going to print 3, then it's going to print 5, then 7. Another way, print all the odd numbers starting from 1. From 1 to 9, exclusive, right? Excluding 9. That's why it's printing 1, it's printing 3, it's printing 5, it's printing 7. A step can also be negative. Then the range will be reversed ordered. Notice the first 2 arguments are also flipped here, right? So print every integer in this range, start from 6 down to 2, decrement by 1, and then print that integer. So we start at 6, we print 5, we print 4, we print 3. So hopefully this made sense using the range function in Python. If again, I think this is one of those things where it kind of makes sense to practice it in the moment. So here we'll say for number in range 10, print number. So this is if we just want to print 10 integers starting from 0 up to 10, excluding 10. So when we run this, it's just going to print 0, 1, 2, 3, 4, 5. Zoom in a little bit. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But if we want to specify what number we want to start on, we can do this. So I'm going to comment that out. Then we can give it both a starting number and an ending number. So this is going to start printing from 1 to 10, excluding 10. So let's run this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And this is the same. Writing this is the same thing as writing it this way, from 0 to 10, right? So we get 0, 1, 2, 3, 4 up to 9, and this one we go from 1 down to 9. So these two do the exact same thing. And then if we want to go from a specific starting number to a specific ending number, but we don't want to increment by 1 anymore, right? As you can see here, we're incrementing by 1 each time. And we want to increment by 2, for example, then we can do it this way. We can just add this third argument in the range function. And now it's going to print 1, 3, 5, 7, 9. So it's going to start a 1, and it's going to add 2. So the next number it's going to print is going to be 3. Then 3, add 2, and print that. So it's 5. Add 2, it's 7, print that. Add 2, 9. I can even do it plus 3, right? And it's print 1, 4, and 7. I can do it plus 4. So it's just going to print 5, and that's it, 5 and 9. I can do it with 5. It's just going to print 1 and 6, right? So I can specify whatever I want. And then if we want this to decrement, then we can do it this way. We can say, hey, start from 10, go down to 1, and decrement by 1. And if I run this, it's 10, 9, 8, 7, 6, 5, 4, 3, 2. And remember, whatever our terminating number is, whatever the end of our range is, it's excluded, right? Now, if I wanted to still print 1, then I will change this down to 0. So now it's going to print 10, 9, 8, 7, 6, 5, 4, 3, 2, and then 1. So hopefully this helped you get a little bit of a better picture on using the range function in combination with a for loop. Okay, here we have an exercise called from negative to positive. It says, please write a program which asks the user for a positive integer n. The program then prints out all the numbers between negative n and n inclusive, but leaves out the number 0. Each number should be printed on a separate line. An example of expected behaviors will be add for 4. It's going to start from negative 4, negative 3, negative 2, negative 1, and then 1, 2, 3, 4. Okay, let's go to VS Code. We gotta just gonna copy that. Number is equal to this, but I'm going to wrap this with quotes. Wrap it again in opening and closing parentheses. Wrap that in an integer input. So now we prompted the user to provide an input, and then cast that or make sure that it's an integer, right? Whatever they type in here is going to be a string, but we want to convert that into an integer so we can do something with it. Okay, so then we're going to say for num in range, and then we're going to say negative number to positive number, print num. Let's see what this does. Python negative to positive dot py. So if we're running 4, it's printed negative 4, negative 3, negative 2, negative 1, and then 0, 1, 2, 3. Now, let me go back here. Is it inclusive? It is. So this should be number plus 1. So now, if we run this again, from 4, there we go. Negative 4 all the way down to 4. But we don't want to print this 0. So now we're going to say if num is equal to 0, actually, if num is equal to 0, continue, then print. I think this might be the way to do it, but let me double check. Let's run our program again. And there we go, negative 4, negative 3, negative 2, negative 1. We don't print the 0, then we go 1, 2, 3, 4. We check if our number is 0. If it is, don't do anything, right? Don't print, just continue. Otherwise, print that number out, print all the other numbers. So let's run our test here, see how we do. And we passed. Send that solution to the server so we can get credit for it. Go back to the browser, refresh that. We got credit for it. Open that model solution in the browser as well. And there we go. So they prompt the user for a number, then for I in range, negative number to number plus 1, like we did, because we want to include that number in our range. Because in Python, bool type equals to 0 and 1, false and true, conditions can also be written as follows. If I does not equal 0, then print I. So this is the same thing as us here saying checking if number is equal to 0, then continue, right? But you can also write as they did. If num does not equal 0, then print num, right? This might even be a little bit more intuitive than what we did. So we can run this and it'll still do the exact same thing, right? So you can do it this way. If num is equal to 0, print continue. Or you can do it this way as they did in the model solution. But that's that. We got credit for this one. So let's keep going. Okay, here we have from a range to a list. The function range returns a range object, which in many ways behaves like a list, but isn't actually one. If you try printing out the value the function returns, you will only see a description of a range object. So here we have a variable called numbers, which is assigned to range from 2 to 7, and then we print numbers. It's just going to print range 2, 7. The function list will convert a range into a list. The list will contain all the values that are in that range. The advanced course in programming course, which follows this one, will shed more light on the subject. So here we can take our range, right, and convert it into a list that we can work with, and then when we print that list, it's going to print this. So again, they're not going to dive deeper into this, but if I had to assume is that range returns a range object, as it's said over here, but we can't do much with this, right? We can't do much with the object itself because what I would assume is this object doesn't have an iterate methodology. In fact, we could probably check this right now, as curiosity will tell us. So here, Python, and see what kind of. So as you can see here, right, it only has an index, a count, an index, start, step, and stop built-in functionality, right? It doesn't have any functions that will let us change our range once it's defined and whatnot. So this is probably why we can't use it as a list. We can't assign it like this and do something with it, unless we're plugging numbers straight into the for loop. Okay, a reminder of the demands of the automatic tests. So far, when the exercises have asked you to write functions, the templates have looked like this. Write your solution here. If you can test your function by calling it within the following block, blah, blah, blah. Well, we've seen this a bunch when we're learning how to write functions in Python. From now on, there will be no more reminders in the templates to use the if underscore name is equal to main block. However, the automatic test will still demand its use. So you will have to add the block yourself when you test your function within the main function of your program. Some exercises like the palindromes exercise coming up in this section expect you to also write code which calls the function you wrote. This function should not be placed within an if name equals main block. The automatic tests will not execute any code within the block, so your solution will not be complete if you place your function calls there. Here we have an exercise called list of stars. It says please write a function named list of stars, which takes a list of integers as its argument. The function should print out lines of star characters. The numbers in the list specify how many stars each line should contain. For example, with the function called list of stars like this, the following should be printed out. 3, 7, 1. Okay, let's prepare VS Code. Okay, so I have the exercise opened up here in VS Code. I've already navigated to the folder where the source with this file is as well, so we can run it down here. Again, I've demonstrated that in the past and even in this video, so you should be able to do this by now in case you don't want to hit the wrong button up here, like I have it disabled. Okay, so again, please write a function named list of stars. So we're going to define a function here called list of stars, and which takes a list of integers as its argument. The function should print out lines of star characters. The numbers in the list specify how many stars each line should contain. So for item in list, print asterisk times item, comma, end, like that. So let's test this. If name is equal to main, then we want to call list of stars 37112. See how this does. Should I save that? Python list of stars.py. Okay, so maybe this might not be the way to go because it's printing everything in one line like that. Okay, that was pretty simple. So we have 3 stars printed here first, followed by 7 stars printed here, then 1 star, then 1 star, then 2 stars. So if we run the tests on this, we passed, send that solution to the server, refresh, got credit for that. We can open the model solution in our browser. And there we go. So I was definitely overthinking it. I thought we were going to have to manually manage the print function here to print the stars in one line, but this was always a solution. I don't know why I was thinking doing and equals would be the way to keep things in line for each asterisk. But yeah, this is a solution, same thing we came up with over here. So yeah, awesome. Now, this is also, we can do type suggestions as we did. So we can do my list like that. And this is just a type suggestion. So when we do call our function here, Python will prompt us like, hey, this function is expecting the argument being passed to be a list. Okay, here we have another exercise called anagrams. I'm just going to prepare VS Code over here to navigate us to this anagrams folder and make sure that we can run our program in the terminal down here. So just give me 1 second to do that. Okay, we're in the exercise 23 folder in the source subfolder. Here we're being told to please write a function named anagrams, which takes 2 strings as arguments. The function returns true if the strings are anagrams of each other. Right? 2 words are anagrams if they contain exactly the same characters. Some examples of how the function should work. So team and meta, true. They're anagrams. Team and mate, true. Tame and team, true. Tabby and baddie, false. Because this has 2 B's, or this has 2 T's. Python and Java, false. They have non-similar letters in here. So we're going to define a function here called anagrams. It takes in 2 strings. So string 1 is a string, and string 2 is also a string. Or a string like that. It's not fully written. Now here we're going to say for character in string 1, for character in string 2, I should say character 1 in string 1, for character 2 in string 2, character 2 in string 2, if equal to character 2 wait, give me a second. I'm writing a mess here. Okay, so this is one of those things where I mentioned in the past that sometimes I would like if the instructions also told you whether or not to use a string. Whether to use a list or whether to use a loop or not, because this can be solved pretty quickly without using a loop. Right, especially down here, when I went back and reread this, gave me a way clearer picture. Right, hint: the function sorted can be used on strings as well. So remember when we used the list function, to convert a string into a list, we know that lists have that sorted functionality, which uh, can sort, lists in ascending or in ascending order, for example. So you can do the same thing with sorted, because with a sorted function with strings directly, because each string is assigned a value that can reorder them in ascending order. So we can use sorted on tame and meta, for example, and it will list them in the same way, where A's come first, followed by E, followed by M, followed by T on both strings, and then you can compare those, which will then return whether or not these strings are true. So I'll demonstrate this on the Python playground in 1 second. Okay, we're on the Python playground here. So if I was to define a function called anagrams, it takes in two strings, S1 and S2. And in here, what we're going to do is first check if the length of S1 does not equal to the length of S2, then we want to return false immediately. Else if we want to check if S1 dot sorted S1 is equal to sorted S2. What's going on here? Unexpected indentation. Then we want to return true. And now here we're going to do if name is equal to main. Then we want to print anagrams. We're going to pass mate, and we're going to pass tame here to check. What's going on? Oh, sorry. This is I keep forgetting this, that Python doesn't have the double equals, just for no equals here. Okay, so there we go. When we do mate and tame, it returns true because mate and tame are anagrams. If we do team and mate, for example, that's also true. But again, to make sure that we always get something returned, we can also do mat, for example, in tame. We're going to get false here because mat and tame are not the same length. But this could, which is what I was thinking about next year. What if we do team and mate like that, right? With an uppercase T, is that going to return? It returns none. So we also got to think about comparing if whether letters are capitalized or not. So we need to convert both these strings to lowercase. And Python has a built-in function on strings called lower, which is going to lower that string to lowercase. Now they should return true. And there we go, true. So even if we were to do something egregious like this, M-A-T-E, like that, it will still return true. So I think that this is going to be our solution. So let's go back to VS Code here. Get rid of this. Define anagrams. S1 is a string, S2 is a string. And we're going to check if length of S1 does not equal length of S2. We want to return false. Else if sorted S1 lower is equal to sorted S2 dot lower, then we want to print, we want to return true. True like that. Then if name is equal to main, for anagrams, we'll pass mate, we'll pass tame. In fact, we should probably go over here and just copy all of these. Then here we'll do Python anagrams.py. Right. Sorry, that's the wrong way to define the argument parameter prompting. Let's run it again, and there we go. We got true, 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 none, and false. Okay, why is it returning none here? True, 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 none, false. Oh, oops. There we go. Let's put this through the test, see how we do. Pass all those tests, submit. Go to the browser, refresh, got credit. Take a look at the model solution. And they did this. They didn't even worry about checking if strings are the same length, making sure that they're lowercase so we don't run into any weird cases where if we uppercase one string and we lowercase another string, that will still work. But this is essentially the basis of our solution, which is being done here. But we just, again, make sure we convert each string to lowercase. Also that we check for the length of each string to make sure that we can avoid any of these issues. So this is our solution. This is the model solution. You can take this one. It's so much simpler, but this one is just a little bit more in-depth, making sure we cover our bases with different scenarios. Okay, here we have another exercise called palindromes. We're told to please write a function named palindromes, which takes a string argument and returns true if the string is a palindrome. Palindromes are words which are spelled exactly the same backwards and forwards. Please also write a main program which asks the user to type in words until they type in a palindrome. Please type in a palindrome. Python, that wasn't a palindrome. Java, that wasn't a palindrome. Okay, I see. All right, so let me go and prepare VS Code again so we can be able to run our program when we write a solution. Okay, so I have VS Code here prepared. We're going to define a function here called palindromes, right? Yeah, palindromes. Takes in a string. And what I'm going to do here is do a for loop. So for I in range length of our string. And we're going to floor it because we only need to check half the string on one end while comparing it to the other half of the string on the other end. So this is going to make sure that we return half the string, but that it's a whole number, even if we have an odd number string. Then we're going to say if string at index I is equal to string at the back end of the string minus 1, then we're going to return true. Otherwise, we're going to return false. So I'm assuming here it just wants us to call the main program should not be written inside the if block. That wasn't a palindrome. Else print string is a palindrome and then break. I'm assuming this is what they meant by this note down here. Python palindromes.py. Please type in a palindrome. Python, that wasn't a palindrome. Banana, that wasn't a palindrome. Taco cat is a palindrome, and he breaks out. So I think that should be one that works. Let's just run this again. Right? This says Python, then Java, not a palindrome, then odd or even. And then finally that is a palindrome. So I think that should be the solution. Let's test this. Test failed. Does not match with the model solution. The printout ABBA is a palindrome. Does not match with the model solution that wasn't a palindrome. Interesting. I think because of the break here. So 1, 2, 3, 4, 5, 6. Because it checks 1 with this, then it checks this with this, and then it checks this with this. It should have returned false. What's going on here? Okay, I see the error. We're returning false here too soon. We need to back it up one more step. So now if we run our test here, we should be okay. Nope, still failed. Okay, the problem was the order of our return statements. I put return true here instead of return true down here, right? And I also reverse this. It shouldn't that it be equal to. It should be that if it's not equal to, then return false. Right, so basically check the start of the string and the back of the string. If those two indexes are not true, break, because we know exactly now that the rest of the string is now going to be a palindrome. Otherwise, keep going. Right? Keep going, keep going, keep going. And if we never return false, then it must be return true. Because once we return true, false or true in a function like this, even if it's inside a loop, then it automatically makes this final return statement from the function that value. Right? So if we return false here early, then the whole function is going to return false. So we need to check first that the indexes are not equal. And if they are equal, then we kick out. We return true, and then, so yeah, that's why I had to reorder this. So return true here instead of return true here, right? Because if we return true too early, for example, when it was like this, then if the first character and the last character are true, then it's going to return true and kick us out immediately, right? It's not going to check the rest of the string. This way, it makes sure that it checks the whole string before kicking us out. So now if we go up here, and run our tests again, there we go, we passed. Send that solution to the server. Go back to where's chat? Where's the link? Right. If we refresh, then there we go. We get the credit for it. We can also look at the model solution. Okay, they did the same thing. They did the same thing. They did the same thing. Only we didn't do it this way. We did it. We just took the index at that, but they took it, the word at the index. This is a little bit weird how they set this up. And then that's also what we did down here. So pretty similar solutions. Okay, here we have another exercise called the sum of positive numbers. We're told to please write a function named sum of positive numbers, which takes a list of integers as its argument. The function returns the sum of the positive values in the list. So I'm going to set this up. Okay, got VS Code set up. We're in the folder. We're going to define a function called sum of positives. We're going to take in a list. And we're going to write here a variable called sum, so that equal to 0. And for number in my list, sum is equal to sum plus number, return sum. Then down here, we're going to do if name is equal to main, that. We're gonna just copy this, honestly. Okay, let's run this. Now this is going to return the sum of every number here. So again, the result is 3. It should be 9 because we only need to add the positive numbers. So here we're going to say if number is less than 0, continue. Well, actually, we should do it like what we learned earlier. If number does not equal 0, then increment sum by the number. I'm sorry, if number is greater than 0, not equal to 0. If greater than 0. There we go, the result is 9. Let's test this. And there we go, send that solution to the server. Go back over here, refresh, got credit for that. We could check the model solution. There we go, for item in list. If item is greater than 0, increment sum by that number, then return sum, which is exactly what we did here. And these exercises will be using lists as arguments and return values. This was covered in the previous sections if you need a refresher. Please write a function exercise called even numbers. We're told to please write a function named even numbers, which takes a list of integers as an argument. The function returns a new list containing the even numbers from the original list. Okay. So I'm going to set this up. Okay. Got VS Code here set up. We're in the right folders. So we need to define this function, which takes in a list. And then we want to return all even numbers. So new list is equal to an empty list. I'm going to say for I in my list, if I modulo 2 is equal to 0, then we want to do new list that append I, right? Was it append? To add to the back to add to a list. Yeah, append. This is the function that adds to the back of the list. Oops, exit. Right? Add that to new list and then return new list. Now here we're going to do if name is equal to main, then we're going to copy this, paste it here, indent. Let's test this out on by ourselves here. There we go. Original is 1, 2, 3, 4, 5, and new is 2 and 4, like that. Let's run this and run the tests. Send those solutions to the server. Show the model solution in the browser so we can see. I'm going to close these old ones. Same thing, they created a new list, an empty list, then iterate through the list that we pass to the even numbers function. Check if that current item we're iterating over divided by 2 returns no remainder. If it does, then we know it's an even number. That way we can append that to our new list and then return the new list. So pretty simple stuff. Refresh that and we're kosher. Here we have another exercise called the sum of lists. We're told to please write a function named list sum, which takes 2 lists of integers as arguments. The function returns a new list which contains the sums of the list of the items at each index in the 2 original lists. You may assume both lists have the same number of items. An example of the function at work. Okay, I see. So let me close this, close that. Just gonna make this a little bit taller. Gonna change directory into exercise 27, sum of lists. go into the source folder. We can go ahead and close this, open that, define our function here called list_sum, which takes in two lists, so L1 and L2. Then what we're going to do is create a new list. We say for I in L1 and for J in L2, new list that append I plus J. Then return new list if name is equal to main. Then I'm just going to copy that, paste it, and see how we do. Python sum of lists.py. Okay, we get 8, 9, 10, 9, 10, 11, 10, 11, 12. Oh, because it's going through, oh, snap. Sum is equal to 0. Let me take a second to think about this. I had a way different idea in my mind until I started putting code to editor here for a second. Okay, so what I ended up doing was just doing, since we're told to assume that our lists will be the exact same length, then what we can do is tell Python to iterate for the length of one of our lists. So it will be for the length of L1 in this example. Then we declare a variable called sum, set that equal to the item at L1 and the item at L2, and then append that sum to our new list. We can also just do it in line here like that. And I think if we run this, we should do the same thing, right? We get 8, 10, and 12. So I think that should work. Let's run this, put this through the tests. The tests passed. Send that solution to the server. There we go. Go over here, refresh, make sure we get credit. We do get credit. We can show the model solution in the browser. Okay. They did the exact same thing that we just did. Another solution will be the zip function. Results for item 1, 2 in zip of list 1 and 2. So we'll have to, this is, I guess, something you can look up on your own, what the zip function is. If somebody wants me to cover this, what the zip, this approach in a different video, let me know in the comments below. But this is also another solution that they suggest. But this is the one that we just wrote here. So yeah, awesome. Here we have another exercise called distinct numbers. It says please write a function named distinct numbers, which takes a list of integers as its argument. The function returns a new list containing the numbers from the original list in order of magnitude, and so that each distinct number is present only once. Okay, let's set this up. We're going to go to the exercise 28 folder. 28 underscore distinct numbers source. Open this up. So I'm just gonna do here first. If name is equal to main, like that, just set that up. Define a function called distinct numbers. It's going to take in a list. Then we're going to do for I in my list. I need to first create a new list. For I in my list, if I not in my new list, then new list that append I. Then return new list. Now, we've seen this. How to explain this? So when we worked with strings in the past, we've seen that if we wanted to check whether a certain character appears in our string, right, or the first occurrence of that item, of that character in a string, we would do, for example, if E in character, for example, then do something with it, right? Dot, dot, dot. Now, this in function works with lists. So what we could have done, for example, is if I in new list, then continue. Else new list dot append I. So check if our current number is already in our new list. If it is, then skip it. Otherwise, append that number into our new list. Now, how do you negate something in Python conditional checks? You do not in, right? So if here when we do if I not in new list, then append I to new list, and then return new list like that. So now here I can go ahead, copy this in our name block here, paste that in. And remember, we have to return this sorted, so it's 1, 2, 3. Because right now, if we were to run it as it is, Python distinct numbers.py, we get 3, 2, 1, right? Because these 1, 2, and 3 are the only distinct numbers. So we need to make sure that this is sorted, so we can get 1, 2, and 3 like that. Now when we do that, we get 1, 2, and 3. So let's run this through our tests. Awesome, send that solution to the server so we can get credit for it. Back on the browser, refresh, got credit. Show model solution in browser. Open that. And they did the same thing, right? Create a new list in our function here, right? We define a function called distinct numbers, takes in a list. We create a new variable here called results, assign that to an empty list. Iterate through our list that we pass into this function. Then check if this current item that we're iterating over in our list does not exist in our new list. Then append that item to our new list. Then sort the list and then return it. So they did results.sort. You can just return sorted results, and I think it does the same thing. So that's the solution for this exercise. We have 3 more exercises and we'll be done with this section. So let's keep going. We're making good progress. Finding the best or the worst item in a list. A very common programming task is finding the best or worst item in a list according to some criteria. A simple solution is using a helper variable to remember which of the items processed so far was the most suitable. This temporary best choice is then compared to each item in return, and at the end of the iteration, the variable contains the best of the bunch. A rough draft which doesn't quite compile yet. So here best is equal to some initial value. Then we iterate through a list. If this item is now better than that current best item, then we swap them. So we set item equal to best, and then we keep going. We now have the best one figured out. The details of the final program code depend on the type of the items in the list and also on the criteria for choosing the best or worst item. Sometimes you may need more than one helper variable. Let's practice this method a little bit. So again, whatever our criteria here could be, like if our best item is the largest item in the list of integers, then we're going to set that. If it's the worst item, etc., etc. Here we say, please write a function named length of longest, which takes a list of strings as its argument. The function returns the length of the longest string. So here, the length of my longest string. I think it's Richard. 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. This one's 7 characters. 1, 2, 3, 4, 5, 6, 7. Also 7 characters. Print results. Why is it printing 8 and 7? Oh, right, for this and this. Okay. Right. This will be the longest one. Okay, so we don't care about returning what the actual item is in the code. We just want to get whatever is the criteria that we're looking for. Length of longest. Okay, let me open this. Define function called length of longest. It takes in a list. Then we're going to say longest is equal to 0 for item in my list. If item, or say length of item, is greater than longest, longest is equal to item, and then return longest. If name is equal to main, then let's just gonna copy this. We'll fix this in a second. Indent everything. Result 1. Set this to B. Result 2. Like that. Let's run this Python length of longest.py. We get 8 and 7. Put that through the tests. Send that solution to the server. Show model solution. Here they define a function called longest of names like we did. Set the helper variable called longest, set that equal to 0. Iterate through the names. This is exactly what we just did. Exactly what we did here. Just a little bit better spacing. Okay, awesome. Go back over here, refresh, get credit for that. Here we have another exercise called the shortest in the list. Please write a function named shortest, which takes a list of strings as its argument. The function returns whichever of the strings is the shortest. If more than one are equally short, the function can return any of the shortest strings. There will be no such situation in the test. You may assume there will be no empty strings in the list. Okay. Just going to copy that. Close this. 0430 shortest in list. Close these, open that, paste that from the previous one. Just need to change the name of the function. So this just needs to be shortest. Same thing here, same thing here. Shortest is going to be the first item in our list. So we're going to say my list at the first index. Now here, if length of item is less than short, set short equal to that item and then return short. Like that. So now if we run it, Python shortest in list.py, we get an error. If length of, why is this not supported? Oh, sorry, length of short. Oh, pardon me. Oh, because this is the string. There we go. And here we get first, and here we get Tim. Run our tests. We passed. Send that solution to the server, and this we can view the model solution, but it's going to be exactly what we just did. So I'm not even worried about it. But let's set this equal to an empty string, which is kind of crazy. And for again, we were told not to assume that no strings are going to be empty, but they still checked for empty strings. But yeah. Refresh this, make sure we get credit for that. Here we have the final exercise in this section called all the longest in the list. Please write a function named all the longest, which takes a list of strings as its argument. The function should return a new list containing the longest string in the original list. If more than one are equally long, the function will return all of the longest strings. The order of the strings in the returned list should be the same as in the original. Okay. Just going to copy that, close that, change directory back to the all longest in list, like that. So longest going to be 0, and new list is going to be an empty list. For item I in my list, if length of item is greater than longest, then longest is equal to item. Actually, this needs to be a string. And actually, what we could do is new list dot append longest. Okay, is this where we left off? I just take a quick phone call. Right, longest is equal to 0, new list is equal to an empty thing. Right, if length of item is greater than longest, what we want to do is set longest equal to length of the item. Then for item in my list, if length of item is equal to length of is equal to longest, then we want to do new list that append item. I think this should work. And list.py. Okay. Let me take a second to look at this. If length of item is greater than longest, set longest equal to length of that item. For item in my list, if length, maybe because I'm using item twice. Okay. Sorry, I'm dumb. Forgot to return our new list. Here we go. We got 11th, 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 and then Richard. Okay, so we're getting somewhere. For item in, was that why? There we go. Because I was using S and then my list and then item down here, so it doesn't know what item is referring to, because the variable here was S instead of item. Okay, so that's the solution, I think. Put that through the tests. We failed. Your code should contain functions named all of the longest. Whoops. All of the longest. Like that. Okay, run this again. There we go. Send out solution to the server. Show model solution in the browser. There we go. I've declared here empty new result list. Iterate through our past list. Right, if result is equal to an empty string or the length of name is greater than the length of result at the first index, right? Basically, if whatever's in here first, right? It's already empty. And then set that equal to result. Basically append that long item into the result array. I mean the result list. Otherwise, do the manual appending If the length of the name is equal to the length of the result as 0. Oh, okay. Here, check if. So this is in the chance that only one thing is the longest, then just put that item into the result list. Otherwise, if we find more items that are as long as our current longest item, that's already being pushed to the result array list, then append that one as well, and then return that array. Okay, that's all for this video. We finished the final exercise in section 4. We're getting very close to the end of section 4, of part 4. We just have these 2 small sections left. And as I showed you guys earlier in the video, let me just close all this stuff, open the TMC, oops, pardon me, TMC extension, go down to part 4, right? As you can see, we're down to the final 1, 2, 3, 4, 5, 6, 7 exercises. So I think we should definitely be done with this section this week. I'm going to try and record those videos, both of them either tomorrow and schedule them to upload later in the week. So we might have not that we might, but we will have another video up on Wednesday and another video up on Friday to conclude this chapter. Or actually, no, we're gonna have this video is coming out Tuesday the 19th. So when you're watching this, will be sometime around 3 p.m. when it launches on YouTube on Tuesday, May 19th. Then the next video after that will be on Thursday, the 21st. And then the video after that will be on Saturday, the 22nd. Or the 23rd. I think it will be the 23rd that Saturday. And then we'll be done with part 4. That way, Monday of next week will be us starting part 5. So thank you so much for watching. If you have any critiques, feedback, suggestions, you can leave them in the comments below. If you had any trouble with the material covered in this video and you need some extra help, let me know in the comments below. I will try to make another video covering some of these topics in more depth. But yeah, thanks so much for watching, and I'll see you guys in the next video.